it's amazing, you know, sometimes I'm doing things and I'm like, boy, I wish I had a spec in, and then you know, because I don't use it that often, so I kind of forget that I have it. But it's a interesting device. We're going to talk a little bit about its features, some of the shortcomings, things like that. It's kind of a mid-level spectrum analyzer. It does really quite a lot. Some of it I haven't even poked around with yet. It can be used standalone, and I'll pass this around when I'm done here. If you have, you know, the eyes of a teenager and the hand of a surgeon, the screen's very small and very fussy about where you touch the screen. There is a GUI-based app that I have that I'll show you here shortly, and some Python scripts, but I'm not a Python guy, so I've never really played with those. The one thing it does not have that I really miss is it doesn't have a tracking generator that will allow you to do like real-time alignment of filters and things. It does have a signal generator, which is really quite good, but you can't run it at the same time you're running the spectrum analyzer to use like a tracking generator. I see QEX has an article in the latest issue on a guy who built one to go with the TinySA. I've thought about building it, but I just haven't got around to it. On the other hand, analyzers with tracking generators generally cost quite a bit more, so it's not a surprise it doesn't have that. This thing called resolution bandwidth, we'll talk a little more about, a little bit limited, but again, I think I paid $150 for this, and it's kind of the mid-level. There's like 3 or 4 of them available, and for that kind of money, man, it's an amazing little box. Well, it's essentially a receiver with various IF filters along with post detection, like noise filters, like you'd have on the audio output of your rig. And it's a lot like a receiver that your little 2-year-old is spinning the tuning dial up and down constantly. And if you do that with like a conventional radio, what you're doing is tuning a local oscillator and moving different RF frequencies down into the IF passband. And that's what happens here. But in a spectrum analyzer, it's not a random thing. It starts at a start frequency, it ends at a stop frequency, and it sweeps across there at a controlled rate. And you can control that rate, you can control the start and stop frequency. Kind of depends on what you're trying to do in terms of how you would set that up. And then the detected signals, instead of going right to a speaker with a radio, they show up on a screen with like a noise floor, and then any signals that are present will show up. Screen's typically animated with frequency along the horizontal axis and amplitude along the vertical. And the amplitude is typically in dBm, but you can set this up to do dBu, dBm, watts. I mean, it's just got a whole bunch of different things that you can choose. And you can set up the start and stop frequencies, and it's got pretty good resolution. So, you know, if you just want to nudge it a little, you can do that. It does not have things like max hold and quasi-peak measurements, which typically, again, are found on higher-end instruments. But I wouldn't be surprised at some point if the firmware for this would incorporate those. And it's got markers, so you can put little triangle markers over points that you want to remember or track. And I did find that the amplitude measurement of this thing is really phenomenal. I mean, if it says you're at negative 26.9 dBm, that's where you're at. And it seems to be pretty consistent over the frequency range. Yes, we have some things at work that are on, what do you call it? Where they calibrate them every 6 months or a year. Metrology. Oh, much less. Yeah. I would say within maybe a few tenths. Yeah. And some of that may have just been my connectors and things. For all I know, it's perfect. You know, I was amazed how close it was. Screen captures or plot storage are available on this. You can save the image, or I think it'll put out a CSV file so that you can recreate the plot with other software. The one thing you have to be aware of is that a spectrum analyzer, it's not a frequency counter. I've used a lot of spectrum analyzers over the years, and some of them do a pretty good job. But if I want to know what that frequency is, I'm saying, okay, the spec ends can get me close. But if I really want to know what it is, I'm going to use a counter. The nice thing about a spec an is if you've got like an output of a transmitter with the fundamental and some harmonics, you pump that into a counter, and what's the counter going to count? The fundamental, this harmonic, that harmonic, and there are ways to address that, but it's a little tedious. The analyzer, you may not have the absolute frequency, but boy, you can sure see them all at once, and you can see their relative amplitudes and things that you're doing, maybe bring some of them down. Very useful. And NUTZ is like the power version of NUTS. Remember I said a spectrum analyzer is a receiver? Well, you wouldn't connect the output of your transmitter directly to the input of your receiver. You might do it once, but that's about it. Sometimes, though, that's exactly what people do with an SA. And you're dealing with an instrument that can read down maybe below a negative 110 dBm. Some of them go quite a bit lower than that. You hit that with, say, 10 watts, and you're going to blow up the front end. So you've got to be very careful with that input. You've got to know what you're feeding it, and you have to have a good idea that you're not going to exceed the input. So I always, and I mean always, with a couple of exceptions, always have an attenuator on the input. You'll see I've got a pad on this one here. It's 10 dB. You're throwing away some signal, and it doesn't guarantee you won't blow it up, but at least you've got a shot. You're going to knock the signal down by 10 dB. Maybe the attenuator will open before you blow up your front end, but unless I absolutely have to, I will always use an attenuator. Might not always be 10, but something. Again, I won't guarantee it, but it might help. Front end repair of a spectrum analyzer is really expensive. Now, I don't think you're going to get this one repaired. Maybe. I kind of doubt it. You probably just get a new one. But in the old days, with the big boat anchor, HP, or some other major manufacturer of a spec an, Rode and Schwartz, you blow that up, and it's going to be thousands of dollars. And a couple of reasons are that it's not just an RF amplifier in the front end. To bring the noise figure down, it's very linear, it's wideband, and it's calibrated. So I had an engineer I worked with at work once that had I think it was an Agilent spectrum analyzer, and he was looking at noise in a switching power supply, and he just hooked it up and blew it up. And I think we ended up replacing it. I mean, and it wasn't because he was stupid, he didn't think it was that big, and it was. So, old school analyzers were all hardware based. They were basically a receiver with like a tuning knob almost. And when you turned them on, they came up. But I think virtually everything today, and certainly this one, it's based on an operating system. It's essentially like most other things today in RF world, it's a computer with an antenna stuck into it. So when you power it up, it may take a while. This one actually powers up pretty quick. But I've got one at work that you power it up, and it literally takes about 8 minutes to come up. And it tells you right off the bat, it's running Windows. It's a computer. So just be advised. And this guy's a 50 ohm instrument, like most RF instruments are. I will have a little whip connected to it because I'm just going to demonstrate some looking at signals. But if you really want to know what amplitude you're dealing with, You really need to plumb it up like you were hooking up a 50 ohm circuit, because you are. You got to pay attention to those interconnects, because something that works great at 10 megahertz probably isn't going to work at 2 gigahertz. So the proper hardware to interconnect things is important. Filters. Well, this resolution bandwidth is probably one of the biggest things in terms of using one of these instruments. It's essentially like the filter in the IF of your radio. You might have a CW filter, you might have a sideband filter, you might have a wide filter or narrow filter. And this is what you're going to use to set the bandwidth of the circuitry that's going to analyze whatever signal is making its way through at the time. And depending on what you're looking at, that might be a wide filter, maybe a narrow filter. You might have to try several different ones. Experience will be a good leader here. Narrow resolution bandwidth can help you separate out closely spaced signals, just like a CW filter in your receiver. But there's some gotchas with that. A real narrow filter, you have to sweep through it slowly, because if you go too fast, you're going to get a lot of distortion through the filter. Make that up with a wide frequency span, several megahertz wide, a very narrow filter. It might take 5 minutes for this thing to go across that span and give you a complete display. So a lot of analyzers, including this one, have an auto setting that says, oh, you're sweeping at this rate and you're sweeping from this frequency to that frequency. Here's the best resolution bandwidth, and it'll pick it. And it usually does a pretty good job, but depending on what you want to see, it may not be the best choice. So again, playing with the instrument and looking at your signals can help a lot. Narrower it is, the slower we've got to sweep, auto setting, and experience. You have, say, an AM signal, and I'll show you one here in a few minutes. And you want to determine if the upper and lower sidebands are at the proper level relative to the carrier. Well, let's say you've got a carrier at 14.3 megahertz, and you're modulating it with a 1 kilohertz tone. And again, we're running AM here, so we're going to have 2 sidebands. We're going to have an upper sideband, we're going to have a lower sideband. And they're going to be spaced from the carrier, each of them, by 1 kilohertz. That's your modulating frequency. Well, if your resolution bandwidth is set to, say, 300 kilohertz, you're not going to be able to separate those out. I'll show you kind of what that looks like here in a minute. Here is that is really too busy a picture, but I didn't have a lot of time to prepare for this. So in any event, that blue trace right up here is like a wide resolution bandwidth. And the fact that it kind of does a little dip would hint that there's more going on there than just that one signal. The yellow one, a little narrower. Now you're starting to see the 2. In this case, there are only 2. And the purple, well, there we've got an even narrower bandwidth, and we're actually able to separate those out. But while that blue sweep might take 2 seconds, the purple one might take 2 minutes. Just depends on the instrument. Well, this is obviously a different instrument, but this is more like what you're going to see when I fire this up. Here's a carrier, upper sideband, lower sideband noise. And that, again, is with the right filter settings. This thing called the video bandwidth. This confused me a lot many years ago when they were talking about this. This is the post-detection filtering. This would be like in your radio, we're down to audio, and you got a bunch of lightning static, and you've got some kind of an audio filter that's going to help reduce that. In an analyzer, they call it the video bandwidth because you're typically looking at the signal rather than listening to it. And it's very useful. You can kind of bring that noise, the grass, down. And it's really quite helpful when you know you've got a little signal hiding in there. It's not very strong, maybe a few kilohertz away from your main spike. You can turn that video bandwidth down, bring the noise down, and here's that little spur right down there. You can actually see it jump out of the noise. This typically also has an auto setting, and that does too. So sometimes you don't have to really worry about it. Depends on what you're trying to do. Well, this guy, this little box, the screen is very bright and very clear, but it's very small. So I'm exaggerating a little, but give me a couple years, it won't be. Okay? The old hardware-based analyzers were limited by the design or cost, if you will, of those resolution filters, bandwidth filters, number of poles, how finely they could be tuned. Whereas today, again, this is a computer with an antenna stuck in it. This is software limited and memory and processor. So, I mean, in 5 years, who knows what these things will be able to do. And it does a good job. You know, I've used some really good HP boat anchors, and this thing does pretty well. I got a good HP analyzer story. Back when I was working in satellite communications, we had a great big HP, beautiful instrument. Many different resolution bandwidths, very narrow, very expensive. And it had a canvas strap to carry it because it's an anchor, right? Well, at the time, the place I was working, all of the shacks for the uplink and downlinks with the dishes were on the roof of like a high one-story building. And there was a ladder to get up on the roof. And so I was working with this guy, Mark. And Mark's a big, bruising guy, younger guy. So I said, Mark, you get to carry the analyzer up the ladder. So he's going up the ladder, and he's doing fine. And the strap comes apart. And the analyzer comes crashing down to the asphalt at my feet. Well, as a nod to HP, the thing was dented, but it still worked. Calibration is good. Sorry?
How about your feet?
Yeah, it missed my feet. No, it hit by my feet.
You would be here.
Right. But I'm getting to the best part. So, Mark comes down, and I'm, geez, boss is not going to be pleased. So we go in, and this was a really interesting guy. You really had to know this guy to fully appreciate this story. But we show him, and we tell him exactly what happened, and he was not happy. And he was, really clearly ready to do something. And he said, Mark was on the ladder? And I said, yeah. You were on the ground? Yeah. Well, did you try to catch it? No, I did not. Nope. So, we got some anomalies with this guy, especially at the lower end. If you try to go like below the AM broadcast band, I think there's something going on. I'm not quite sure. And not to knock this instrument, but it is true that you can set this thing up such that you think it's not working because it's not updating. And then you look at the little green line down below that shows you how the sweep is progressing. And it's moving very slowly. So you just got to wait sometimes. And this app that I'm going to show you, I don't know. I mean, there are times when I've been using this and the thing is clearly not communicating, or maybe it's locked up. And I've turned things off. I've rebooted the computer. I've started the program first. I've started the analyzer first. I've unplugged it. I've plugged it in. And it just seems like sometimes it's lost its mind. But I've always been able to get it back. Now, I don't know if that's something I'm doing wrong or if it's software. But when it works good. You just got to be a little patient. Some of these functions that I haven't even looked into yet, they're not very intuitive. They're clearly able to do some things with this box that I'm not familiar with, that I haven't seen before. So that's going to take a while to sort that out. And I did mention it has another output or another SMA connector, and that's a signal generator. And it works very well. but you can't run both at the same time.
So you need two of them.
Two of them, sure. And this is a really good site. This is the organization that is behind this thing. And they have a wiki, and I have a printout of some of the wiki that I'll pass around. But I just wanted to spend a couple of minutes going to that site because they do have some really good information there. They've got the different models here. Mine is the second one here, the TinySA Ultra Z S405. And it basically goes from 100 kilohertz to 800 megahertz, or up to 5.3 gigahertz with ultra mode. I'm not really sure what that is yet. Calibrated up to 6 gig, and it can observe signals up to 12 gig. I mean, that's a piece of work. That's amazing. Generator can go from 100 kilohertz, 800 megahertz with a sine wave, which is not your everyday generator. That's pretty nice. Square wave up to 4.4 gig. And this thing has a built-in calibration, self-calibration routine, and you connect the signal generator output to the input of the analyzer, and it does some kind of switching back and forth between the two and checks the calibration. Looks good. It's got a micro SD card you can plug in. I don't have that in there because it doesn't come with that. I think you have to provide that. And over here is where you really get into some useful stuff. There's a lot of good information over in here about, the menus and the buttons and, everything you do. And it's written pretty well, but there's a lot of information here. So you really got to take your time and go through it. And I got my unit from, is it STL? RNL. It was about $150. They have the usual disclaimer of be careful where you buy your from, because there are a lot of clones out there, and some of them I think are fine, and some of them are horrific. So, for $150, I'm going to get it from the place that apparently is the place to go.
Yeah, they recognize places on Ollie. RNL gives you more access.
Yeah, it does come with a number of cables and
I don't think the Ollie
just a box, yeah. Well, here's this app that you download, it's free. There may be other ones out there now that I'm unaware of. You can use it as just like a basic thing and set your start-stop frequencies, your resolution bandwidth, your video bandwidth. It can do some averaging. You can set markers, and you go down further into some of these choices, and there's a lot here, stuff I haven't even played with. But the display is quite nice, and if I turn on my little crystal oscillator here, we should see it pop up here at about 7.03 megahertz, if it hasn't lost its mind. I wish it had that little green progress bar. What are we doing over here? We're getting close. There it is. So that is the signal from this little crystal oscillator that I built years ago, just as like a little marker generator. I can plug crystals in and find them on a receiver. It doesn't really have an output port, it just radiates. So I'm using the little antenna here. It looks like I've got a little too much signal, so I'll back it off a bit. These guys are noise spikes that occurred when I turn that unit on. When it refreshes here, those should go away.
What bandwidth are you running that at?
This is at the auto setting, which sets it in this particular instance to 200 hertz is the resolution bandwidth, and the video bandwidth is also, I believe, 200 hertz, which is the minimum. Okay, so that's just, a signal. It looks fairly wide, but that's really a function of the resolution bandwidth, the filter. What I'm going to do now is I've hooked up an audio generator to the collector of this little oscillator transistor, and I'm going to modulate that with an audio signal. We'll wait for it to wake up here. It's a cursor you can move around, and it'll tell you the frequency and the amplitude at that point. Yeah. Upper sideband, lower sideband. Right? And if I change my audio frequency from, what am I at here? I'm at 3 kilohertz. Put it down to 2 kilohertz. Let it refresh. If you had a high quality HP, say, and you had similar settings, it would look very much like that.
So this is every bit as good from a display standpoint, measurement standpoint.
Does it have some averaging thing where eventually it'll show you all the noise that will get averaged out?
It does have some averaging functions, like here. I haven't played with those, so I really can't tell you what they might actually do, but the wiki, I think, would answer that. They go into some pretty good detail. But I'm going to see if it'll behave, and I'm going to change the resolution bandwidth from auto, which right now is at 0.2 megahertz, or 200 hertz, excuse me. And I'm going to go up to 3 kilohertz. This is sometimes sort of the thing kind of goes off in a never land, but oh, it should, yes. There.
Oh.
Yeah. So, you know, you can kind of make an analog to this, that if you're listening to 20 meter CW and you got a wide filter, you know, you're going to hear somebody calling down here, you're going to hear somebody here, you're going to hear somebody over there, and they're all just going to be in the pass band at once. So you gotta have some familiarity with the instrument to really make it do what you want it to do. And if I go back here and put this back at auto, and then I go, where did it go? Well, I'm not going to worry about that right now, but this should come back. And I'll just turn the audio off, and we'll go back to just a carrier. I was really surprised I get this oscillator to modulate like this just by tying an audio signal into the collector. No, I took a 0.1 cap to block DC right off the collector, and then like a 2 millihenry RF choke to keep RF out of the audio generator, and then that's where I hooked up the audio. So I'm basically just doing this to the collector voltage. And I think that is about all I've got, actually. You mean resolution bandwidth? 2 kilohertz? With the big... Yep, I can do that. Yeah. You also have a points per scan. That's how many sample points there are across the range. You can play with that and get a little effect on your sweep. Yeah, I don't know what that is. It looks to me like some kind of an anomaly, you know, that some number is getting bit structures wrong or something, I don't know. Well, in my view, a VNA or a vector network analyzer, whatever version or type it is, I would pick that to be able to look at the characteristics of a load, a filter, an antenna, maybe to design matching networks. I'd be looking at the input to a transistor amplifier, and I'd be playing with matching networks to see what effect I'm having.
DNA basically has that tracking error.
It does. Right.
the same place you're looking at.
Right. Yeah. And a lot of the VNAs today will let you look at, just a plot of SWR or scattering parameters like S11, which would be like an input parameter. Or if you really want to keep yourself up late nights, a Smith chart. Right? And you can see how things change over frequency. So it's more of a load-based tool in my view. This is more of an active circuit-based tool where I've got,
This is like looking
although it's probably like a Swiss Army knife. If you get creative enough, you could probably make both these instruments do different things. I mean, the first thing that would come to mind for me with a SpecAn would be with the proper attenuation between your transmitter and the spectrum analyzer. You'd be able to see your fundamental and your harmonics, and you would be able to trust the amplifier or the amplitude levels. Yeah. Something else that I haven't used this instrument for, but different analyzer, is tuning duplexers for like a repeater, where you've got a pass set of cans and a notch set of cans. And it's really nice to be able to see these notches and peaks moving as you're tuning these and get them right on the place you want them. Makes it a lot easier. So, and then the repeater keys up and blows up your analyzer. I saw that actually happen once. That was, oh geez. Like I said, this thing is like a cornucopia of RF stuff. I haven't explored it all. And the battery life is amazingly good, So, yeah, it's quite the deal. Oh, another great analyzer story. Again, worked with a bunch of engineers who were designing a new flow meter, and these things all have switching power supplies. Nobody uses mundane linear supplies anymore, and those things can tend to be very noisy. And again, this was the engineer that was probing and blew up the analyzer. Well, we go out to one of these test facilities. At the time, it was called ITS here out in Oakdale. And they have a big chamber, and you put your unit in there on the table, and the table can rotate, and they got the big antenna that go up and down. And they close the door, and the guy's getting all his instrumentation ready. And they're real modern analyzers, but he's got several of them, and a bunch of other signal measuring devices. And he says, okay, I'm set up, turn on your product. So the engineer turns it on, and the noise floor on every instrument pegs. And the guy's eyes, I swear it was like a cartoon. They're coming on, turn it off! So turn it off. That's the worst I've ever seen. You got to get in touch with the manufacturer of that power supply and have them fix it. And the engineer went, that would be me. But to his credit, he fixed it. He got it noise way down, and it passed. But the guy just about had kittens. Well, that's all I got. Yeah.